You know that feeling, you ask your chatbot a question, you get a pretty good answer. You think, okay, great.
Mhm.
But then, I don't know, 10 minutes later, you ask it the exact same question. I mean, word for word.
And you get something completely different.
Completely different. And it just feels like a glitch. I mean, we're all taught the computers are these logic machines, right? 2 plus 2 is always 4.
Right. Same input, same output.
Exactly. But with AI, I type in A, and sometimes I get B, sometimes I get C, and sometimes I get a whole essay on the history of the letter A. Is it a bug? Is it a feature? What is going on?
It's definitely a feature, though maybe characteristic is the better word for it.
Okay.
And that exact thing, that unpredictability, is really the heart of the source material we're looking at today. It's a paper called The Paradoxical Nature of AI by Anna Gatchens from February 9, 2026.
Okay, let's unpack this.
Mm.
Because what Gatchens is basically saying is that AI has just shattered this golden rule of computing that's been around for, what, decades?
That's precisely it. And so the mission for this deep dive is to really explore why that rule, same input, same output, is dead when it comes to modern AI.
And what that means for us, for how we use it, how we trust it.
Yes,
Yeah.
because this isn't just a technical quirk. It's a fundamental shift in, well, the whole philosophy of technology. We're moving from a deterministic world to a probabilistic one.
So let's talk about that golden rule. The source calls it the comforting mantra of computation.
It really was.
Yeah.
For 50 years, it was the bedrock of software engineering.
The safety net.
The safety net, exactly. Think about it. If you're building traditional software, you give it an input, you expect one result. If you don't get it, you know something's broken.
Right.
And because it was deterministic, an engineer could, as Gatchens says, drill down to the exact step where things went wrong.
It's like following breadcrumbs. You can always trace your steps back to find the one wrong turn.
You could debug it line by line. But Gatchens makes the point that with modern AI, we're talking generative and agentic AI here,
Yeah.
that safety net is just, it's gone.
Because these systems are non-deterministic.
They lack repeatability.
Yeah.
And she makes this comparison that I think is really striking.
Oh, I know what you're going to say. That they're like human beings.
Yes. Which is a huge statement.
Yeah.
Humans are consistent. If you ask me what I want for dinner tonight versus tomorrow, I'll give you two different answers, even if I'm just as hungry.
But, I mean, humans are variable because we're emotional, or we saw a taco commercial or something. Why is a machine variable?
Well, before we even get into the why, it's interesting that the source notes this seemed to catch even the pioneers of the field by surprise. People like Geoffrey Hinton and Yoshua Bengio.
The godfathers of deep learning.
Right. Gatchens suggests they had a bit of a blind spot. They were so focused on experimental results. You know, how well does it translate this? How well does it recognize that?
They were just trying to make it work.
They were trying to make it work. And in that race for performance, the bigger philosophical implications of creating a non-deterministic intelligence might have just flown under the radar.
That's wild. It's like building a car that drives perfectly, but every so often it just decides to take the scenic route on its own.
And you can't really ask it why.
So, okay, let's get into the mechanics of it. The why. The paper gives 3 big reasons. But first, can we even stop it? Can you just tell the AI to knock it off and just give you the math?
Technically, you can. An engineer can force a neural network to be deterministic. They do it by fixing the random seed.
Fixing the seed sounds like gardening.
It's basically telling the system's internal random number generator to start from the exact same spot every single time. And if you do that, you can get the same output.
Good.
But Gatchens argues that's artificial. It's not how the AI naturally behaves. You're forcing it to be something it's not. The natural state of these things is flux.
And there's that temperature knob that people can sometimes see, right? That plays into this.
Exactly. If you set that temperature to 0, the model gets very rigid, very repetitive. But the moment you turn it up, even a little bit, you're inviting unpredictability. You're increasing the generativeness.
Okay, so once we turn up the heat, Gatchens says reason number 1 for all this chaos is something called random initialization.
This goes right back to the beginning, to the moment a model starts training. A neural network is made up of, well, millions or even billions of variables, little dials that need tuning.
And when you first turn it on, they're not all set to 0.
No, they're initialized randomly.
Wait, hold on. Why? That seems so counterintuitive. We're talking about precision engineering, the most expensive computer systems ever built. Why would you start with randomness instead of a clean slate?
It's a great question, but it's actually a classic problem in machine learning. If you set every single one of those dials to 0, They all look identical.
Okay.
So when the model tries to learn, every single neuron gets the exact same feedback. They all update in perfect sync.
Oh, they all just become clones of each other?
Precisely. The brain never develops any complexity. It's called the symmetry problem. You actually need that initial randomness, that noise, to break the symmetry so different parts of the brain can specialize.
So you need chaos to create order.
You do. But that means from the very start, you're setting the stage for different outcomes. Two models trained on the same data, but with different random starting points, will end up with slightly different personalities.
Okay, that's already pretty chaotic. But reason number 2. This is where it gets really interesting. This is the part that kind of blew my mind. The curse of dimensionality.
This is a heavy one, but it's so important for understanding why your chatbot feels like it's just guessing.
So the source talks about the solution space. What is that?
Okay, so imagine you're looking for the best answer to a question. In a simple program, the space of all possible answers is maybe like a small room. You can check every corner of that room to find the absolute best one.
Simple enough.
With a massive neural network, the solution space is not a room.
Yeah.
It's an ocean. Actually, it's much, much bigger than an ocean.
And this is where Gaetjens drops that fact that just stopped me cold.
Yeah.
She says the number of possible answers grows exponentially, and it becomes many, many orders of magnitude larger than the number of atoms in the universe.
Let that sink in for a second. There are more possible internal configurations in a large language model than atoms in the known universe.
I can't, my brain just can't process that. So if the library of answers is bigger than the universe, how does the AI find the book I'm asking for?
It doesn't. It can't search the whole library. It would be impossible. So instead, imagine this. You're dropped into a massive, rugged mountain range in the middle of the night. It's pitch black, you've got no map, and your job is to find the lowest point in the entire range.
The deepest valley.
The deepest valley, which represents the best answer, the one with the lowest error. So what do?
It's pitch black. I'd probably just start walking downhill.
Exactly. That's what the AI does. It's a process called gradient descent. It just feels the slope of the ground beneath its feet and takes a step down over and over.
Okay, but what's the problem?
The problem is, in a space that big, you might walk down into a pretty deep valley, hit the bottom, and think, great, I found it. This must be the lowest point.
But because it's dark, I can't see that 10 miles away there's a valley that's twice as deep.
You are stuck in a local minimum, thinking it's the global minimum. The AI finds an answer that's good enough. It finds a valley that works.
But because the mountain range is bigger than the universe...
There are billions of these good enough valleys. And depending on where you were dropped in to start, remember that random initialization, you're going to walk down a different path and land in a different valley almost every single time.
That makes so much sense. So when I ask my question 3 times, it's like I'm dropping the hiker into the mountains 3 separate times, and each time they find a different good enough answer.
Precisely. The AI is always just giving you the best answer it could find on that particular journey.
That is just staggering. Okay, so random initialization is where we start. The curse of dimensionality is the giant foggy map. What's reason number 3? Dropout.
Dropout is it's a tactic. It's something engineers do on purpose during training.
On purpose?
Yeah, to prevent the AI from basically memorizing the data too closely, from overfitting.
How does it work?
Well, the source describes it pretty clearly. During the computation, selected neurons are just omitted. They're turned off. And they're usually chosen randomly.
So parts of its brain are just being shut down while it's trying to think.
Temporarily, yes.
Why on earth would you do that? It feels like trying to learn something while parts of your brain are randomly going numb.
Think of it like a basketball team that has one superstar player, the LeBron James of neurons.
Okay.
The rest of the team might get lazy and just pass the ball to LeBron every time because he always scores.
Sure, that works. Until LeBron gets injured.
Exactly. If the model relies too heavily on one specific neuron or pathway, it becomes brittle. It can't handle new information. By using dropout, by randomly benching your star player during practice, you force the rest of the team to learn how to score.
Ah, I see. So you force the network to find other ways to get to the answer.
It builds redundancy. It makes the whole system more robust.
Right.
But the side effect is that the team plays the game a little bit differently every time, depending on who's on the court.
You make it more flexible but less predictable.
That's the trade-off.
Okay, so we have a system that starts randomly, searches a space bigger than the universe, and has parts of its brain turned off while it thinks.
It is a perfect recipe for unpredictability.
Which brings us to chaos theory, the black box problem.
Yes.
Gaetjens mentions the butterfly effect. And I think we all know the pop culture version of this, but how does she apply it here?
She uses the classic example.
Mhm.
A butterfly flaps its wings in Beijing, and that tiny disturbance cascades and eventually causes a hurricane in Kansas.
Small cause, huge effect down the line.
Right. Now think about how a large language model works. It's not looking up a finished answer. It's generating it one single word at a time,
It's a chain
a
reaction.
chain reaction. So let's say, because of all the randomness we've discussed, the model chooses to start a sentence with the word however instead of the word but.
A tiny, tiny difference.
Almost meaningless, right? But now the entire context for the next word has shifted, just a tiny bit. The probability for the third word changes, and the fourth, by the time you get to the end of the paragraph.
That one little word choice at the beginning has sent the whole answer down a completely different path.
The butterfly was the word however, and the hurricane is an entirely different conclusion. A single neuron firing just a little differently at the start can lead to a massive change in the final result.
And that's why debugging is impossible. You're looking for a single butterfly in a simulation bigger than the universe.
And this is what Gachens calls the explainability problem. Even the experts who build these things admit we don't have a great explanation for why they're so effective.
We know that they work, we just don't always know how they got there.
We can't see inside the black box. And she makes a really critical point here. We don't even know if the useful answers we get are consistently the best answers. We literally can't know because the AI ignores a different part of the search space every single time.
So, where does this leave us? We have this incredibly powerful but inherently chaotic tool. What are we, the users, supposed to do with that?
Well, this is where Gachens gets a bit more philosophical. She actually quotes the poet Rainer Maria Rilke.
I'm always here for a good real quote.
She says the wise strategy is to learn to love the questions rather than making a goal of just prompt resolution.
Learn to love the questions. That feels so counterintuitive for technology. We use a calculator to get the number. We use Google to get the answer.
But an AI isn't a calculator. It's not a database of fixed facts.
It's a creative search process.
Exactly. When you talk to an AI, you're not just retrieving a file. You are collaborating with a chaotic system that's navigating a sea of probabilities.
So the takeaway for anyone listening is don't just accept the first answer you get as gospel.
I would say don't treat any single output as the final word. Treat it as one possibility. Know that if you ask again, you might get something better.
Yeah.
Or worse. That variability is just part of the tool.
It's like we need to change our whole mindset from seeking accuracy to one of exploration.
That is a perfect way to put it. We're exploring that solution space with the AI.
It really changes how I look at that blinking cursor. It's not waiting for a command, it's getting ready to roll a billion-sided die.
And that's not an exaggeration.
So before we wrap, there's one thought that's been sticking with me through this whole conversation. Gachens tells us to love the questions because the answers are always changing.
Yes.
Well, if the most advanced intelligence we have ever created is inherently unstable, random, probabilistic, does that maybe suggest that the whole idea of certainty is outdated?
That's the big question, isn't it?
Maybe the future of knowledge isn't about being right or finding that one single best answer. Maybe it's about navigating the probabilities, surfing the chaos, and just being okay with good enough.
A very humbling thought for a species that really likes to be right.
Absolutely. Well, thanks for joining us on this deep dive into the paradox of AI.
My pleasure.
Keep asking questions, everyone, even if the answers change. We'll catch you next time.